Hello, hello, hello. Today we're talking about factoring. I know factoring, probably the best thing that ever happened to you in Algebra 1. You probably had so many fond memories, and you just couldn't wait to get back to those days. Well, guess what? We're going back to those days. We're actually, well, actually not sadly, I love it. That's going to be the rest of this semester, all about factoring and different types of factoring, what that looks like. Okay, so ideally by the end of this lesson, you'll be able to describe the relationship between the linear factors of quadratic expressions and the zeros of their associated quadratic functions. You'll understand what that means in a second. And then solve quadratic equations having real solutions by factoring. So you'll see kind of like the first half is really understanding how to factor, and then the second half is knowing how to actually solve quadratics. Um, a little bit of review on the first day of class. When I say first day, that being the day we had actual in-person class via Zoom. I said this statement: roots, solution, zeros, and x-intercept all mean the same thing. You know, I still kind of stand by that statement somewhat, but not really at the same time, kind of distancing myself from that statement. Again, the statement being roots, solutions, and zeros and x-intercepts, those four words all mean the same thing. Now, the reason why I bring it up, because this is where it comes in handy. And it's important to make that distinction. Yes, it's maybe sound kind of nitpicky, I'll say that, but it's really important that you understand that there is a distinction between those four. Now, I feel like I failed you, so I need to bring in a special guest to come redeem myself to kind of explain what Mr. Michael was saying that first day of class. Now, to tell you the truth, didn't think we'd get him here in time. He's pretty popular, pretty famous, so I was really surprised that he agreed to come on. So really, you and your household want you to pay attention, give him your utmost respect, because we have a star in our building. Again, a star. So let's bring him in. Let's bring him in. Let's bring him in.
This one, the campfire song. Let's gather around the campfire and sing our campfire song. RCAMPFIRESONG song. And if you don't think that we can sing it faster, then you're wrong. But it'll help if you just sing along. CMPFIRESONG song. CMPFIRESONG song. And if you don't think that we can sing it faster, then you're wrong. And it happens if you just sing along. CMPFIRESONG song. Good.
Oh, this is on. Oh, hi. Hi, my name is Justin Timberpod. Testing, 1, 2, 3. My name is Justin Timberpod. You may know me from a couple of different classics. I actually composed this little song here, Campfire Song. Now, yes, the creators of that lovely show, SpongeBob, credited me with this. You just look at the credits, you'll see this here. But I am calling in a favor for Mr. Garcia here. He's a really good friend of mine. Him and I go way back in the day. And that Mr. Garcia fellow is so old, too. You probably didn't know that. He's like a good old 72. But we go back in the day, he actually composed a lot of my hit singles. So hopefully you guys don't want to hear about that. My bad. You guys don't want to hear about that, do y'all? Now, you guys want to hear about this factoring, don't y'all? Yeah, you guys want to hear about factoring. Factoring actually goes along to music. Man, I wish I could tell you. I don't know how it goes in music, but I think it does. So, what is factoring? Now, before we understand factoring, I hear that Mr. Garcia needed to clarify a couple terms for y'all. So, I just happen to have here, and I'm about to move this mic out of the way so you may not hear me too well. There we are. Perfect. So, I got here just a little things to clarify what Mr. Garcia was talking about. Those words, roots, solutions, what is that, zeros and x-intercepts, they kind of mean the same thing, but not really the same thing, all right? So what I mean here, whenever you have an expression, okay, so notice here, just some variables, just some letters, that's going to have myself a root. When I got myself an equation, notice here it's an equation because there's that equal sign right there. It's going to have a solution. Same thing, but as well, when we got a function, so specifically f of x, that's going to have zeros. And a graph over here is going to have those x-intercepts. Biggest thing here between equations and functions, this one is f of x, this one is y equals, the word zero just reminds me of my bank account. It's a whole bunch of zeros. No other numbers, but a whole bunch of zeros. So, yes, a little bit tedious, isn't it? But you need to know it, don't you? Just like stuff in mathematics and music is a little tedious, but it gets you famous. Now, you guys interrupted one of my favorite songs. So if you don't mind, I'm going to just finish it out with a little guitar solo. So again, I wrote this back in 87 and modified it in 88, 89, and 98 as well, and also in 2010. All right, so let's finish this out. My bad. Let me get the mic back in. Testing. 1, 2, 3. Testing. Okay, we're good now. All right. It'll help if you just sing along. Oh yeah. Throw it back to you, Mr. Garcia.
Okay, wow, yeah, thanks, Justin. Justin Woodpond, thank you so much for that performance. You guys can catch him on Instagram, Twitter, Spotify, whatever streaming platform you guys have. Make sure to hit him in his DMs because mainly his Instagram DMs. He's trying to pay off my student loans and he's not responding to me or my messages. He kind of just changed the topics right now when we were speaking together. So make sure to hit him up there because I need to get those paid off. But just to review what he was talking about, yes, technically there is a distinction that needs to be made between roots, solutions, zeros, and x-intercepts. My bad. Right there, cool. Yes, in theory, they are all talking about the same thing, but really for us, this first half, we're going to talk about expressions, and then we'll be talking about solutions. I want to save this really for in-class time, so like next Tuesday. But in terms of today, whenever we factor our expression, we'll have some roots. All right, and then from those roots, we'll have some solutions. Biggest thing between biggest thing between equations and functions. Functions have to pass. Just different than function tests. Really, you may have learned that as like the vertical line test. As the other hand, for equations, not necessarily. Yes, both of these have inputs and they give you an output. You typically call this output y, and typically, well, that's a hard word to say. Typically call this output f of x. In theory, no, I'm not going to like say, oh, you said roots instead of solutions. Oh, you're banned from the class. I'm not going to say that. So factoring, I will show you a lot of different stuff today, but this is just the most basic form of factoring. Now, we won't really discuss greatest common factor or really difference of two squares in this class. But for right now, factoring, we'll look at the case where my a value is equal to 1. So what does that mean? So in our standard form, ax squared plus bx plus c, if the number out there in front of the x squared, so your a, if that is 1, so if there's like no number out there, if it's just a 1, here are some ways we can factor. So first off, it must be in standard form. And to factor, we're looking for two numbers such that when you multiply them, the product is c, so this c, and then when you add them, the sum is b. Now, I think I have an example here. I have an example, okay? So I want to get two numbers such that when you multiply, get you 24. So you'll see me do this here. When you multiply, get you 24. And then when you add them, get you your b value, which is 10. So again, notice my a value was 1. So the number in front of your x squared, it was just 1. I always recommend by finding the factors of 24. So what two numbers when you multiply get you 24? You always have 1 and 24, 2 and 12, 3 and 8, and we got 4 and 6. In class on Tuesday, I'll show you like a little shortcut of like how to find those factors pretty quickly. But for right now, 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So right now, of these 4 pairs, they all fit this first criteria. All of them, if you multiply them by each other, will get you 24. So first part done. But now of those 4 pairs, we need to narrow them down such that when you add them together, get you 10. Well, 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11, which is close. But 4 plus 6. So if I was to say 4 times 6, that would be 24. And 4 plus 6 would be 10 as well. Looks like a positive 4 and a positive 6 will fit my criteria. So I'll just write it out right here. So with the expression x squared plus 10x plus 24, that can now be rewritten as x plus 4 and x plus 6. Notice the question was saying just a factor. Since I'm just factoring, that's it. I'm done. So a couple things here. One, you don't necessarily need to put the 4 first and then the 6. If you want, you can say x plus 6, then x plus 4. Doesn't really matter. That's all up to you. That's just notation at that point. Another thing, we took this value. Since it was positive, we said x plus 4. Since it was positive, we said x plus 6. If this ends up becoming negative, one of these answers was negative, then we'll say x minus that number. Final thing here, how do I know if I'm right? How can I check to see that I'm right? Now, on Delta Math, it won't ask you to prove, and I won't ask you to prove as well on any pre-test or any post-test, I guess, at this point. However, for your own benefit, if you're like, I have one try left on Delta Math, I don't want to start this question all over again, how can I check if I'm right? Take your original equation. Take your factored form. You're trying to say here that x plus 4, and let me move this out of the way, x plus 4 times x plus 6. You're saying that's the same thing as x squared plus 10x plus 24. How can you prove that? Think back to last week, multiplying two binomials. Yes. So think back to your FOIL method, your distribution method, your box method, whatever one of those 3 you ended up doing. For the sake of being consistent to what a lot of you guys will do, I'll go ahead and use FOIL. Okay. So multiply my first 2 terms. I'll do it like this. Yeah. X times x. That would be just x squared. Multiply your outside 2 terms, so x times 6. That will end up becoming 6x. Multiply your inside 2 terms, so 4 times x. That'll be 4x. And then multiply your last 2 terms, 4 times 6, which would be 24. And obviously here you can combine those middle 2 terms, x squared plus 10x plus 24, and hey, those look the same. So that means we're good. So that means x plus 4 times x plus 6 is our factored form. So you'll tend to see that whenever you have a value of 1, it's actually not that bad. It's kind of nice. So here, next question, x squared minus 6x minus 16. Again, I'm going to start off by finding the factors of 16. Notice I'll find the factors of 16, not negative 16. I mean, that's subjective at that point. It doesn't really matter. But 2 numbers that multiply to be 16, you can always do 1. It's even, so we can do 2. So 2 times 8. And I happen to know that 4 times 4 would be 16 as well. Okay, cool. What are we looking for again? We're looking for two numbers such that when you multiply, gets you your C value. Remember, your C value is negative 16. And two numbers such that when you add them, get you your B value, which is negative 6 in this case. So of this list, of those three pairs, I need one pair that will meet both of those criteria. Now here's the thing. The last example was kind of nice because these were both positive. So I didn't have to worry about signs. But now in this case, I do have to worry about signs. So that does tell me a couple of things. One, I know one of these numbers must be negative, solely because a negative times a positive equals a negative. I do know that both of the numbers won't be a negative. Only one of them, because if they were both a negative times a negative is a positive, which we want a negative in this case. Okay, then, so let's just kind of work through this in my head, or in our head, not my head only. Take each of these pairs and add and subtract them. If you get pretty close to a value of 6 or negative 6, that'll be good. So if I take 1 plus 16 or 1 minus 16, that'll be 17 and negative 15 respectively. Or same thing in the opposite direction. That won't be anywhere near negative 6. What about 4 and 4? Well, we know negative 4 times 4 is negative 16. But if I was to add these two together, that'd be 8. If I was to subtract them, that'd be 0. So that wouldn't be negative 6. It looks like we're stuck with 2 and 8. All right, so we know that 2 times 8 is 16. And if we make one of those negative, it would end up becoming negative 16. So we're good in that first case. We have to kind of see which one needs to be negative. Well, we need to take a number, add another number, and still get a negative in the end. So if I made the 8 a negative and 2 a positive, negative 8 plus 2 is negative 6. And if I checked it on the top term, negative 8 times 2 is negative 16. So here, this leads us to say that with the expression x squared minus 6x minus 16, that is the same as x minus 8 and x plus 2. Again, negative 8 times a positive 2 was negative 16, and negative 8 plus a positive 2 was a negative 6. Let me highlight it here. This negative 6, we found it from saying that's our b value, which is why it's so important we need to be in standard form. And that negative 16 was found there. So I think I have one more example of what a is 1. I do. Awesome. So same thing here. Find the factors of 24. So 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And what am I looking for again? I'm looking for two numbers such that when you multiply, get you negative 24, and two numbers when you add, that gets you a positive 2. So again, add and subtract each of these pairs together. If you get somewhere in the ballpark of 2, that's great and that's awesome. From there, we'll assign our negatives. So 1 plus 24 is 25. 1 minus 24 is negative 23. That's not going to work out. 2 plus 12 is 14, but 2 minus 12 is negative 10. That's still not going to work out. 3 plus 8 is 11. 3 minus 8 is negative 5. Yikes. 4 plus 6 is 10, but 4 minus 6 is negative 2. Oh, negative 2. So we can work there. We can have some wiggle room there. So it looks like it has to be 4 and 6. All right. So if we do 4 minus 6, that is negative 2. but we want a positive 2. So let's say 6 minus 4. Or 6 plus negative 4, which is the same thing. Again, doesn't really matter here. Oh, my bad. Let's check if it meets the top condition as well. 6 times negative 4. Oh, that equals negative 24. Oh, that's good then. Nice. Because here, again, I can say that the expression x squared plus 2x minus 24 is now going to be the same thing as x plus 6 and x minus 4. If I wanted to, I could multiply those two binomials together, just like what we did on the first example, by FOIL, by distributive property, by box method, and I would get x squared plus 2x minus 24. Again, if I multiply it and I don't get that, that means that my binomials were off, but we're good in this case. So isn't too bad, but this happens only when a is equal to 1. So I guess that begs the question, what happens when a is bigger than 1? So again, the standard form is ax squared plus bx plus c. What if that value of a was 2 or 4 or 6 or so on and so forth? What happens? Well, one, if you have a GCF, which just means, and I'll write it up here, GCF is greatest common factor. If you have a greatest common factor, you must factor that out before applying one of the methods I will show you. What does that look like? What does that mean? So if I give you the expression 4x squared plus 6x plus 10, if you notice there, they all have a number in common. The number they all have in common being 4, 6, and 10, they all have a 2 in common. So I can divide by a 2 in all those expressions. So instead of saying 4x squared plus 6x plus 10, I need to write 2 parentheses 2x squared plus 3x plus 5. And then this inside part, this parentheses, from there, that's where I'll apply my methods, okay? You may see this on Delta Math. I'm not too sure. I have to look on what the assignment is altogether. However, if you try to apply one of the methods that I'm going to show you, you will get a different result. You'll get a wrong answer. Okay, I'm trying to save you from that. But that is only if. You must check that. I'm going to show you three different methods. I don't care which method you select. I want you to select the method that you know the best. You probably learned one of these 3 methods back in Algebra 1. Again, the grouping method I'm going to show you will come very much in handy for the rest of Algebra 2, as in like second semester Algebra 2. The other 2 methods are just great and handy in case you're kind of like struggling with this. So either method works, doesn't matter, you just got to pick. All right, so let's start off with the first method called grouping. You'll notice a common theme I must do first. So if you forgot already, standard form is ax squared plus bx plus c. Okay, step 1, multiply your a term times your c term. So a times c, which would be 3 times 10, that'll be times that point, that'll be 30. So step 1, multiply your a term times your c term. Step 2, write out the factors of that a times c. So the factors of 30, well, we can always do 1, 2 and 15, 3 and 10, and then 5 and 6. And then from there, if we kept going, we'll be repeating. Step 1, multiply a times c. Step 2, find those factors. Step 3, it's going to look similar. Okay, it will look very similar. Find 2 numbers such that when you multiply, it gets you 30. And 2 numbers when you add, it gets you 11. So notice this second part, it's very, let's not use black as a highlighter. This second part It's very, very similar to what we just did. Two numbers when you add to get you your B term. The only change here is two numbers when you multiply, it gets you that A times C term. So between those four pairs, we need to pick one that will get us 30 when you multiply and 11 when you add. Well, in this case, they're all positive, so that's not too terrible. Well, 1 plus 30, or nah, that won't be 11. 2 and 15, it'll be 17, and 2 minus 15, negative 13. Nope. 3 plus 10 is 13. Not 7. Oh, what about 5 and 6? 5 plus 6 is 11, and 5 times 6 is 30. So that's nice. So again, 5 and 6 works for us. Now here is where it gets a little bit different, all right? So I'm going to rewrite this expression I have up here. 3x squared plus 11x plus 10, okay? I'm now going to rewrite this by splitting up this middle term. So this middle term again was 11x. But what I'm now going to say is 3x squared plus 5x plus 6x plus 10. So a couple things here, don't get freaked out. I did not change this 3x squared. I did not change this 10. All I did was split up this 11x, and I split it up as 5x plus 6x. And hey, notice between these two terms, those were these numbers here. And so this is why it was important to find two numbers that add up to be 11, because I can now split up this 11x as this term plus this term. Okay, I'll say that one more time. I split up my B term, which is the middle term, as two separate terms. 5x plus 6x is 11x. I haven't done anything mathematically incorrect here. These are still technically the same expression. Almost done. Almost done. So we're going to factor out a greatest common factor. So a greatest common factor between the first two terms and then between the last two terms. All right. So between 3x squared and 5x, think back to Algebra 1 when you did greatest common factor. You want to factor out what they have in common. So ask yourself, okay, do they both have some variable? So 3x squared and 5x. They both got an x in common, right? So I can take out an x from this first term. I'll do this here. Well, 3 and 5. Is there a number that goes into both 3 and 5? Did they have a GCF? No, the biggest number that goes into 3 and the biggest number that goes into 5 is just 1. So it looks like I could only take out an x here, which is fine. So when I factor out an x, or I take out a GCF of x, I'll have here let me get it in black. I'll have a 3x plus a 5. If it helps you, just divide by that GCF. Okay, so when I did 3x squared divided by x, I got 3x. And when I did 5x divided by x, I got 5. Same thing here. Figure out, okay, what can I take out? 6x and 10, I can't take out an x. That's not possible. Oh, but I can take out a number because they're both even. So what's the biggest number that goes into both 6 and goes to both 10? Actually would be 2. So I can take out and if it helps you, I'll just say 2. I can take out a positive 2. I'll say plus 2. So when I take out positive 2 here, I'll do that 6x divided by 2, which would be, let me get black, which would be 3x. And then 10 divided by 2, which would be 5. Hang in there, we're almost done. What do you notice about this last line I wrote? the stuff inside the parentheses is the same. So what I'm going to do is write the stuff that's inside the parentheses and then write everything that is left over. Okay, so I'm going to write everything that's in the parentheses, which is 3x plus 5. I'm also going to write everything that's left over, which is x plus 2. Now, if I'm trying not to make this video too long, but if I was to multiply these two binomials together, that would give me 3x squared plus 11x plus 10. Now, let's say you're like, wow, that was terrible, that was horrible, I hated that so much. Luckily, I have a different one for you. This is called borrow from brother. I like this one, and it works every single time. There's some caveats in there that are kind of weird, and what I'm planning on doing as well is I'm gonna post another separate video just for grouping, another video just for borrow from brother, and another video for my last method as well. Okay, so if you're like, I need more grouping practice, you'll get more practice. Okay, borrow from brother, same thing as the first step. Multiply 3 times 10, which is 30. The whole concept for borrow from brother is essentially I want to go back to where my A value is just 1. That was nice. That was easier, and it wasn't as stressful for me. So that's the mentality is I want to go back to saying A is 1. So what's stopping me from doing that? Well, clearly what's stopping me, let me get this here, it's my laser pointer, is this 3. This 3 is stopping me. So what I'm going to do is let's get rid of that 3. All right. So by getting rid of the 3, and I probably shouldn't have wrote that. My bad. To get rid of the 3, I'm gonna take that A term and multiply it by my C term. A times my C. And so I'm gonna rewrite this expression as x squared plus 11x plus 30. Hey, the A is 1 now. Oh my goodness, I love that so much. That's so easier. That's a lot better. Okay, so now let's go back a few slides. Let's think about what we did. Okay, cool. Find the factors of 30. So I know 1 and 30. I know 2 and 15. Was it 3 and 10 and 5 and 6? Sweet. This is a lot easier. Actually, this is very similar to what we did. I think, is it the same one? It looks really familiar. But two numbers, and I'll do it here. Two numbers when you add, not 30, my bad. And I'll do this. Sorry, I just say consistent with what I'm doing. Two numbers when I multiply gets you 30. And when you add them, gets you 11. So of those 4 pairs, the pair that's going to work the best is going to be 5 and 6. So that says that 5 times 6 is 30 and 5 plus 6 is 11. So between x squared plus 11x plus 30, we can say that is now x plus 5 and x plus 6. Yay! But didn't that seem kind of weird to you? I just told you in the very beginning, hey, just get rid of that 3. Just multiply by that 3 just because you want to. You generally can't do that in math just because you want to do something. Just because I want to get rid of the 3, you can't just like multiply by 3. That's generally frowned upon. So let's kind of reverse that action, okay? We need to make sure we're good. Let's reverse that action. So we're going to divide now. So let's reverse the action of multiplying by dividing. And since we multiply by 3, let's divide by 3. Notice here I'm only dividing the number by 3, okay? I'm not worrying about the x. I'm just worrying about the number alone. 6 divided by 3. I feel confident on that, right? That's just 2. 5 divided by 3. Ugh, that's a decimal, right? You know what? We don't really like decimals. So here's what I'm going to do. This is going to look messy. I'm trying to think if I can do this. I don't like decimals. I don't like fractions. Let's get rid of that fraction, but let's not make it a decimal. So since I couldn't simplify that number anymore, that 5 over 3, I want to take that 3. I'm going to bring it right there in front of the x. And so that's going to end up saying that's 3x plus 5. And hey, we got ourselves the same answer, huh? So that would be kind of awkward if we did a different method and we didn't get the same answer. Again, that was a lot there, and I'll make sure to include some more examples in a different video. Box method, yes. Very similar to grouping, essentially. It's very, very similar to grouping. It's just more of a systematic approach. Okay, so you'll notice this first part for box method is still multiply your A times your C, so that'll be 30. If you notice, with these three methods, that was the first step. Multiply your A times your C. Sweet, between there, we need to get two numbers that multiply to be 30. Again, nothing too crazy here. We've done this a couple times already. And guess what? We're still doing the same thing. Two numbers that when you multiply, get you 30. And then when you add, gets you 11. Hopefully that isn't a surprise by now. And hopefully it shouldn't be a surprise that the numbers that work are 5 and 6. So we can end up saying here that 5 times 6 is 30 and 5 plus 6 is 11. Okay, so I mean, that was literally the first thing that we did for the rest of them. Hopefully that isn't too much of a surprise. Now, here's where the box method comes in handy. What if I didn't like the grouping method? I want to keep it more systematic approach. So let's draw a box. Box, we'll do 4 little boxes within this box. Okay. That first term was 3x squared. That last term was a 10. And if you can put positive 10 if you want. But these diagonal pieces, I'm going to replace this 11x with these two terms. Again, instead of writing 11x in one of these two boxes, I'm going to replace that 11x with a 5x and a 6x. Doesn't really matter which one you place in which. That's just up to you at that point. I'll just go ahead. Oh, my bad. I'll go ahead and say a 5x here and a 6x right here. Should have made my box a little bit bigger because I got plenty of room here. So the whole purpose of this is we're still finding the greatest common factor. But now we're finding it by looking at our rows, and then looking at our columns. Okay, so let's look at this first column, 3x squared and 6x. Take out your GCF. So what number do they both have in common between 3 and 6? Okay, they both have a 3 in common. That's the biggest number I could take out. So between 3x squared and 6x, I could take out a 3. Can I also take out an x? Oh, I can, because they both have an x in common. So between 3x squared and 6x, I can take out a 3 and an x. Okay, so that was the first column. Let's go to the next column. Next column being 5x and 10. So biggest number you can take out between 5 and 10 would be 5. Can I also take out an x? Well, do they both have a variable with them? Do they both have x's? No, looks like the 10 doesn't have an x. So that's all I can take out there, a 3x plus 5. That's fine. So that was both of the columns. Now let's go to the rows. So let's start with that top row right there. The top row being 3x squared and 5x. What is the greatest common factor? Okay, for the number, 3 and 5. I can't really take out a number there. I can only take out 1. Can I take out any x's though? I can. This has an x squared and this has an x. Therefore, the max amount of x's I can take out would be only x to the first power. Cool. Let's try this next one right here. 6x and 10. Okay. 6 and 10. The biggest number to take out there would be a 2. 2. So I can take out a 2. What about a x? Can I take out any variables there? And if it helps you, I'll put a plus here as well. Can I take out any variables? Looks like I can't take out any variables. Oh well. But that's fine because let me rewrite this. I'll write the expression on top and I'll write the expression on the side. 3x plus 5 and x plus 2. And hey, this looks awfully familiar, doesn't it? Again, it'd be totally awkward if we did that and got completely different answers. That would be really awkward. I will make separate videos for grouping, for borrow from brother, and some people call this, I think it's cherry picking. That's a common thing I hear as well. And there's also different methods I did not discuss in this video. Okay, different methods where I saw that, hey, that's just how people do it. Now, I think what I'm going to do, I'm called audible. I'm going to stop the video here. There's a lot more to this video that we're not cover. I'll adjust the syllabus and the schedule. So for right now, this is a great thing for you to look at. Kind of look at whatever methods you have and see which method you like the best. From there, select the next video down below of like, okay, I want to view more of this type of method or more of this type of method or this method. Okay? If not, you guys have a great rest of your day. I will see y'all next time.